All right, welcome back. This is CS50 week 2 sections, and today we're going even deeper into C, talking about arrays, command line arguments, and strings. For those who are here for the first time, my name is Yulia, and I am a preceptor here at Harvard. I help run the class here on campus. But as I mentioned, today we're talking all things C, right? Taking even a deeper dive from what we talked about last section, and today that's arrays, strings, command line arguments, or CLAs for short. So without further ado, let's dive right in. And first thing I'm writing today is arrays, right? So with another week, we're adding another layer of complexity, right? Another step that we need to take to make our programs run a little better, more efficient. So how use arrays and why use arrays? Well, consider this kind of website, which it might be something that you will implement as a final project in the end of this course. And this was a website implemented by some of the students where they collected some information about how, folks slept last night. For example, how many hours did they sleep last night? How many times they snooze alarm in the morning? So, for example, consider we want to store the number of hours that people slept last night. Well, how could we do that? One option is to just have a bunch of variables, right? So for example, on Monday, I slept for 7 hours. On Tuesday, I slept for 9 hours. And I'm just storing all of these variables randomly in my memory, in my computer, and not really connected together, right? Well, this is where arrays come in. Wouldn't it be nicer to just have everything sort of like continuously together, right? One after another, where, for example, Monday is the first box that we're seeing on the screen, Tuesday is the second box, etc. So by storing this information into arrays, we're sort of like ensuring this continuity of the flow of information. Well, with arrays, there comes another layer of syntax that we need to learn. Firstly, every array will have a name. It will have a size, right? Like one of the other specifications, we need to tell how big this array will be. And there has to be a specific type. In this case, it is int. So for example, this kind of array that we just saw on the screen would be declared as such: int hours, square brackets 5, where we say this array will be of data type int or integer, its name will be hours, and the size will be 5, meaning that there will be these like 5 boxes stored all together. Well, there are also certain characteristics that we need to talk about when it comes to arrays, and one of them is size. So right, as we mentioned, that's something that we need to tell the computer from the very beginning how big this array will be. Well, in fact, arrays have fixed size. So we will actually learn how not to make them fixed and how to dynamically make them bigger. But for now, sort of like the assumption that from the very beginning, we need to tell how big the array will be. Second characteristic is the type. So as you might have noticed, a few slides before, we had just integers, right? Like just numbers. And in front of our hours array, we put int to tell the computer that we're going to store integers. Another quirky thing about arrays is that it can only be one type, right? We can only store all integers or all strings or all characters. In C, we can't really mix and match them, but we will actually see that it is in fact possible to do when we get to a language such as Python. But for now, another characteristic about arrays in C is that they can only be one type, but sort of like has to be one type for one specific array, but you can pick whatever type you want. And another interesting thing about arrays that might be new for this week is how do we access them, right? Like before, we would just pick a variable name, for example, hours1 or hours2, and we know that a specific value or number is sort of like stored in this little box that we can just grab from there. Well, arrays are slightly different, right? We have this like continuous flow of information. These little boxes are cells that we can access, and so how can we do that? Well, each array has each sort of like part of the array has its own index, right? And that is how we access this information, these values. So for example, if I wanted to grab the first value in array hours, I would say hours square brackets 0. And this is another thing about arrays in C and sort of like in general in computer science we're now learning is that it is zero indexed, right? For example, you might have seen in week 1 that when we were printing out a Mario pyramid, we started with int I equals 0 and not int I equals 1, and that is because in computer science we count from 0. So in the same way that we count from 0 when we write for loops, we index from 0 when we need to access some information in the arrays. Well, we've talked about different properties and, how arrays are built and how we can access information. How do we create these arrays, right? How do we populate each cell with the value that we want? To do that, we can do the following. So for example, in the very beginning, you say int hours square brackets 5. This will sort of like allocate, these like 5 cells in the memory. And the computer will know that we're going to put integers into them, and they're going to be exactly 5 cells that we're going to populate. And as I mentioned before, to populate these cells, we can index into them and then put a specific value into it. So for example, you can imagine having these 5 cells all in a row, and when I type hour square bracket 0, you're sort of like stepping into one of these cells and you're putting number 7 in there, right? And when I say hour square bracket 1, you're going to the second cell, so like stepping into it, putting number 9 in there, and now it is recorded. Well, there's another way to initialize and populate the array, and that is sort of like doing it all continuously. So for example, if you know from the very beginning all of the numbers that you want to put in to the array, you can declare it and populate it in such a way. No one way is better than another, depends on, what the purposes of your program are. Maybe you want to populate the array step by step, or from the very beginning that, hey, I'm going to have these 5 numbers, so I'm going to put them in right away. Okay, this was a lot, a quick run through of what arrays are, how to access values, some of the characteristics, but what questions do we have about arrays and sort of these small details about them? What questions do we have? Feel free to type them in the chat, folks. Gonna give it another minute in case people have any questions. Is an array a list? Different, right? We have lists in Python and also lists, for example, in R, if you're familiar with that kind of language. I would say the concept is similar, but it is like a different data structure, right? An array. If I want to populate the array with another variable value, how to do that? So in the same way that we assign values right here, you can change them, right? So for example, if I change my mind and I was like, oh, no, on Tuesday I actually slept 10 hours, I can again just use the square brackets, 1 index, and then change the value to 10. Someone asks, is there a limit to how many values we can store in an array? Sort of yes and no. You can make arrays, like as big as you want, but if you're going into like a billion, a trillion, right, or like even a little less than that, you might consider using some kind of other data structure or a more efficient way of recording things. Do we always need curly braces to store values? That's a great question. So this way is just one of the options of how to, populate the arrays. So if you're using this kind of syntax, yes, like this is how you would structure it. But there's also an option of populating the array 1 by 1, or also using for loops, as we're going to see in just a second. Any other questions about arrays? All right, well, feel free to drop them in the chat as we're going, but now let's move on to our exercise. So our first exercise will be creating an array of size 5, where each element is 2 times the previous and the first element is equal to 1. We will then print the array integer by integer. So let's move over to cs50.dev. Feel free to follow along or open up cs50.dev on the side as well and work on this together. But let's get started. First, I'm going to create a program called arrays.c. Pops up right here. And I'm going to populate it with some standard things, right, that we always do. I'm going to include standard IO. Okay, I'm going to create a main function. All right, and let's leave ourselves some comments, right, to guide our way through this exercise. So first what I'm going to do is I'm going to declare an array. Declare an array. Then I'm going to populate an array. And then I'm going to print out the values 1 by 1. All right. So if I want to declare an array, how would I do that? How can I declare a new array of size 5? Any suggestions? Exactly. So int array 5. And what it does is, again, sort of creates these 5 blocks where we will put our integers because we specified the data type ints. Perfect. And now let's just go ahead and populate it with some values. So as our guideline said, the first, let's call it numbers. All right. So the first value will be 1. And then all the subsequent values will be the previous one times 2. So we want to make sure that we are sort of like correlating them together, right? One way to do that, it would also be just like saying 1 times 2 and then 2 times 2, et cetera, et cetera. But since we have this like kind of like guideline that we can just grab the value from the previous cell, we can just do that. So I'm going to switch this back to number 0. All right, and let's just do it a couple more times. So numbers 1, now times 2. Okay, and then numbers 3, now times 2, and then lastly, numbers 4 equals numbers 3 times 2. Okay. All right, so this was a lot, right? Like a lot of sort of like copying, pasting, and doing the same thing over and over. And I sort of know what my values are going to be like, right? Like I know it's going to be 1, 2, 4, 8, and 16. So the other way to do that is also just populate it right away with the curly braces that we just saw. So in a very similar way, and I'm going to comment this out, but we could do int numbers 5, right? Again, giving it a specific size. And then in the curly braces, I can just say 1, 2, 4, 8, 16. And these two are interchangeable variations of how to populate an array. Okay, and lastly, I want to print out the values 1 by 1. And I see someone already suggested a for loop, but maybe that was a different part. But this is where we also could use a for loop. So we could declare it as we always do for int I equals 0. Then I is less than 5, I plus plus, right? Meaning that we want to go through each of the elements 1 by 1, printing them out. And in the same way that we just use indices to, go into our specific cells just above to populate them, we can do the same thing here. The only difference is that now we're using I, right? That is incrementing as we're going through the for loop, not just, like hard coding the specific numbers. So here we can use %i as our placeholder, move over to the new line, and now say numbers I right here. Okay. Looks about right. Let's try to make it. So make arrays. Yay, it compiles. And now let's run it. Okay, so I think we're seeing what we want to see, which is great. 1, 2, 4, 8, 16. Perfect. How could I make this program a little better? It runs, right? Like it is printing out the values that I wanted to print out. We were able to populate it, but how could I make it a little better? You want to type some options in the chat. How could I optimize this? Okay. We can declare the array values in the loop. Exactly, yeah. So instead of doing all of this and, like copy pasting it over and over, what I could do is create sort of like a similar for loop where I'm going to populate values one by one. So maybe in the very beginning, I'm going to say that numbers 0 is equal to 1, right? To just give ourselves a starting point. And then now, instead of int I equals 0, I'm actually going to start it at 1 because we already know what will be stored in the first place. I'm still looking to iterate all the way through. So I still less than 5, I plus plus. And now right here, what I'm going to do is sort of the same thing, right? So numbers I would be equal to numbers I minus 1 times 2. So what will happen here is when my I is equal to 1, right, when I'm just starting my for loop, by the time I get to line 12, I will substitute i's with numbers 1 equals numbers I minus 1 times 2, right? So it will be in the second cell with index 1, put the value that is number square bracket 0 times 2, which will be 2, right? Because we populated the array with value 1 right here. Okay, so let's try to make it. Oops. It's going too fast. This should be I. Okay, let me clear this. Let me make the terminal slightly bigger. Let me run arrays again, and we're seeing the same thing, right? Okay. So someone suggested that we print out and populate within the same for loop, maybe here. Why this suggestion would not work in here? And let's maybe demonstrate what it would be. Let's do numbers I. And I'm going to comment this out for just a second, okay? Make arrays. So now I'm seeing 2, 4, 8, 16. Why is that the case? Why am I not seeing 1 now printed out? Right, because my I is 1, right? Like my starting point is the second cell, not the first cell. So I'm really not grabbing this guy right here. So instead, we are creating a second for loop. The other way to do it would be to come up with some other solution where you don't have to initialize it to 1 before the for loop, and maybe you can combine these two all together. I would argue there is one more area of improvement, and it is avoiding this magic number 5, right? For example, if I know Carter looks at my code tomorrow and they see 5, they're like, where did that come from? Like, right? What does 5 mean? So as Professor Malan said in lecture yesterday, a better way to do it, or a better design, would be declaring it as size from the very beginning. Here, I sort of know that my size will always be 5, so I can just declare it as constant here. And instead of having these magical 5s all around, I'm just going to replace it with size throughout my code. Okay. I'm going to make arrays again. I'm going to run it, and it still runs as we intended. Okay, so This would be slightly better design, right? Like that what we had in the very beginning. We're using a for loop to populate an array instead of it going step by step, line by line, copy pasting it essentially. We got rid of this magical number 5 and now substituted with size. And now it'd be so easy if I wanted to, for example, change it to 10 or change it to 8, right? I don't have to go into multiple places to do that. Any questions about this exercise or arrays? Yeah, and I'm seeing some suggestions in the chat. So we could do numbers square brackets 1 as in the very beginning in the array, in the for loop, and sort of like get rid of that. All right, any other questions? All right, seeing none so far, so maybe let's keep moving forward. And now we're going to talk about strings, right? So it is again, once again, another layer of data structures, of types that we're working with. And we sort of saw it last week when we used getString to get the user's name and then print it out. But I would argue that there are more things going on underneath the hood, right? Like there are more steps than just grabbing the word from the terminal. So consider it a string hello, right? And we would declare it as we do with all of our variables, giving it a data type, a variable name, and the value that it needs to store. So what it actually is, it's not just a string, right? And we'll actually learn that string doesn't really exist as a data type outside of CS50. But for now, let's just think about it as a string. Well, what's actually going on is it gets separated again into these little cells, with each character being an individual cell, right? So what does it look like? It looks like an array, right? So actually arrays, I'm going to skip forward here for just a second. Strings are just arrays of characters or chars. And some people might say cars, but in this section we're saying chars. So strings are just array of characters. And so in the same way that we just index into array hours, we can index and access values in string word. So in the same way as before, the array will have the indices, right? So 0, 1, 2, 3, 4. And sort of like the length of the string is 5. But I would argue there is one more element that we're missing right now. And I think I might have spoiled a little bit while I was skipping forward. But what other element is technically also there that we don't see on the screen? Exactly, the null. So every string has this null character that will be in the end to sort of like specify, okay, this is where my string ends. So I think in the lecture, David demonstrated that if we don't know the length of the string, or like before you knew the function strlen, what you could do is just use a while loop and iterate through the entire string, and this null character will specify the end of it. And so this is how we know we've reached the end of the string. So this is how strings relate to arrays. And let's keep moving forward. So again, going back to our original slide, how we would access these characters. So in the same way that we did with the arrays before, right? As you remember, arrays can store any kind of type. So integers, characters, longs, floats. So we can access all the values in the same way. So for example, if I typed word 0, I will see letter H. And if I typed word 1, I will see letter E. And this is because when you create a string, it is sort of like stored continuously, right? So they're not just like scattered around where H is there and then E is there and then L is somewhere in between. They're all in one place, one after another. So that is why I can index into them one by one. Well, we also learned that all of the characters are numbers, right? So we now see the ASCII chart that we've seen so many times before in lecture, and even last week and this week too. So this is how the letters and numbers correspond. But what does that have to do with strings? Well, actually, again, what computer sees is not hello, but actually the numbers, right? So H will be 72, and then E will be 101, and there is this like correspondence between the letters and the numbers using the ASCII chart. And again, the very last element will be 0, because the null character in the ASCII chart world is just 0. So as I mentioned before, strings are just arrays of characters where we can work with them in the exact same way. In a few weeks' time, we will also see that strings actually don't exist, right? It's not a data type outside of CS50. It is actually something a little different, but we will close our eyes for that this week, and we'll just assume the string is a thing. And next, we're gonna go and do an exercise to get a little practice with strings. But before we move on, what questions do we have about strings? How to access them, maybe their relationship to arrays, or if people have any leftover questions about arrays that we just talked about. What questions do folks have? How can the computer know if it's a char or an int? Yeah, that's a great question. So I guess it sort of like depends like how you also output it to the user. So we'll actually see it in just a moment. But if we want to print out characters, we would use a %c placeholder. But if you want to print out the number that this letter corresponds to, we would print out %i. Oh, so many questions. Alrighty, let's see if I can get through all of them. How do we traverse the words in a sentence? That's a great question. So one way to do it is maybe recognizing the spaces. So maybe something that would be helpful for readability, be said this week. And see, it's a little trickier, right? Because you have to go one by one. So you might still need to come up with a more elegant algorithm. But spaces are usually a good sort of like split point between all the words. Let's see. When making an array of certain size, do we start counting from 1 or 0? We always want to start counting from 0, right? So be it the for loop, unless in the for loop you want to make some other conditions, but by default we start counting from 0 and indexing from 0 as well. So this is kind of like our starting point. And I know it gets a little confusing when we say index 0, but we say the first place. So lots of sort of like interconnected things here. Let's see. How can we represent voice or video on ASCII? Oh, that is a great question. Maybe something worth Googling, but I'm not exactly sure how to help you here. Alrighty, let's move forward. And feel free to type more questions in the chat. But for now, our exercise would be checking if a lowercase strings characters are in alphabetical order. If they are, we're going to print out yes, and if no, we're going to print out no. So let's go back to cs50.dev right here. I'm going to clear my terminal. I'm going to close this file and open up a new one. Next, I'm going to create a new file called alphabetical.c, and so it will show up right here. And I'm going to again pre-populate it with some of the common things. So for example, I'm going to use CS50.h library, and I know this just because I prepped before sections, so I know exactly what libraries I need to use, but you should really just be careful with libraries you include. You don't want to include all of the libraries that exist out there, because then it is just getting too much. So I'm going to also include string.h. I'm going to create the main function, int main void. Okay, so again, as before, let's leave some comments for ourselves, right? Like, let's guide ourselves through this exercise, and this is what a lot of problem sets encourage you to do, right? Like, pseudocode your steps before you even get to writing code. So this is exactly what I'm going to do here. I'm first going to get user's input, right? I want to get the word that I need to check from them. I'm then going to iterate through each element in the string. And then I'm going to maybe have some if statement that decides where it's alphabetical or not. Check if it is alphabetical, and we'll talk about it in just a second of how exactly to do that. And then I'm going to print out yes or no. Okay. So first, let's get users input, right? Super straightforward, something that we've done a lot last week. And then if someone wants to type in the chat, what would that be? What do we want to use here to get users input? Get string. Perfect. So get string, and I'm going to say input space, colon space. Going to put it on a new line, semicolon. Okay, perfect. So let's make sure that it compiles. So make alphabetical, alpha, this is gonna be a difficult one. I'm gonna keep messing it up. Input, hello. Okay, so that works. And then maybe let's get rid of the new line just so that it is in line with our input. All right. So next, we're going to iterate through each element in the string. And again, anytime you see iterate or go one by one, you immediately think for loop. So this is exactly what I'm going to do here. I'm going to say for int I equals 0, because I'm always starting from 0. I'm going to say I is less than what, right? If I say hello, I know it's 5 characters. If I say Yulia, I know it is 6 characters, right? So how can I dynamically determine, right, how long my word is? And someone suggested using strlen. Exactly. So this is what we're going to use here. So strlen text. Okay, and then I++. And now in here, what I'm going to do is just print it out for now, right? Let's see what is stored. What characters do we have here? So I'm going to use %c, which is used when you want to print out characters. It might be a new thing, but very similar to the idea of %i or any other placeholders. And in here, I'm going to print out character by character. So text I right here. Okay, let's make sure it compiles. Make alphabetical. Let's run it. Input hello. Okay, and I get hello. Maybe let's put a space just so that we can see it one by one. Okay, so characters hello. How do we check if it is alphabetical, right? Like I as a human can now see that like, okay, hello is not alphabetical, right? So that wouldn't work. But computer doesn't really know alphabet, right? Like it doesn't really mean anything to it. How can we leverage what we just talked about to check for alphabetical? And by alphabetical, I mean like the order, right? Like for example, A, B, C, D, like that would be the right order. Okay, so someone suggested if text square brackets 0 is less than text square brackets 1. And do we compare letters here? Like is H less than E and is E less than L? Does computer know how to compare letters? Someone says write an array and compare it to it. That's also an option. But someone said maybe using the ASCII chart value. Exactly. And this is where we're going back to our correlation between the letters and the numbers. So for demonstration purposes, let's do this here. So I'm going to print out a character and then a dash, and then I'm going to print out the ASCII value associated with it. So I'm going to put another comma here, and then say text I again. So let's see. Okay, so we see that each letter, and I'm going to zoom in here so that it is more visible. So we can see that each letter has a corresponding number to it, right? According to the ASCII chart. Okay, so now that we know that, let me clear the terminal, go back to my code. What kind of condition would we want to set in here to actually check. So someone suggested text 0 is less than text 1, right? Like that would work if we had like 2 letters, but what is the dynamic aspect of this for loop, right? Like what does constantly change that we can use to compare the letters? Any ideas? So text 0 versus text 1 was a good intuition, right? But we just want to make sure that it is updating as we're going through our word. What condition do we want to set here? Okay, so text I is less than text I plus 1. Okay, that's a good intuition. Let's try something different. So let's do text I is less than text I minus 1. So what I'm going to do here is I'm actually going to start at int I1, right? So I'm going to start from the second place. And then as I'm going to look backwards, right? So every time I go, I look at the previous character, and then I determine if the ASCII value is greater or not. So let's do printf here. So basically, this is what it's saying, right? So if, I cleared the terminal, okay. So if text I minus 1, right, if the next character is indeed bigger than the first one, then we want to quit, right? That means that it's not alphabetical, and we might as well just finish right now. So we're going to say no here. And the tool that would allow us to quit immediately is return, right? So if I return right away, right here, it's not even going to check the next lines, right? Return means exit right now, we completed the program. And this is exactly what I want to do, because if I didn't have return 0 here, for example, and then let me delete this part. In the end, right, I would print f yes, if indeed I didn't catch any of my letters in this if statement. But here's where the issue comes up. So let's make alphabetical, hello. So it prints no, yes. So the reason why it's happening is because we don't have a return here, right? The program just keeps going on. We are not telling it to stop. So instead, if we put return 0 here and let's recompile and run it again, it'll just say no immediately, right? And it will exit because I get to line 13 and I see that E is indeed, my condition here is not met, so I want to print f no and exit right away. Right, and if I didn't do that, I run into an issue where it says no and then yes, and that's just not what we want. Someone said, why 0 and return 0? So I think David mentioned a little bit in the lecture, but they're different exit codes, right? And they're mostly for the computer. We don't really see 0 printed out on the screen, but the convention is that 0 is used for success, and then all the other numbers are used to signify special sort of like error codes. So even if we're printing out no, right, the program is still successful. It ran and identified that it is in fact not in the alphabetical order, so we still return 0. But any questions about this part, right? This is just a really good example of how letters and numbers connect together through ASCII, and this would be a really powerful tool as you're getting through this week's problem set, but also just like thinking about different data types. Any questions about this part? So someone asked, how is the system understanding we mean the number value associated with the char, not the character itself? That's a really good question. So as we saw before, right, when we used %c or %i, it would print out different things. %c would print out the letter itself, and then %i would print out the number. This is how we can specify when we are outputting it to the user, but internally in the system, it knows that I'm not trying to compare H and E as letters, right? Like it sort of like goes like level deeper and compares it as numbers because they're sort of like interchangeably exist in computers. Someone asked, does string have dynamic allocation of memory? Is there a limit to dynamic allocation? Again, yes and no. Like, there are definitely limits of how far you can push, but as you're just like working, for example, with strings or any arrays, like, you're certainly okay. And we will talk more about dynamic allocation in just a few weeks' time. Okay. What other questions do we have about this part? All right, seeing none for now, so let's go back. And now let's talk about command line arguments, right? Or CLAs. It's actually one of my favorite topics. I think it is so fun to sort of like jump from just get string and get int and sort of like level up into using something else. But what are some examples of programs we've seen that take command line arguments? Even if we might not have called them command line arguments, we've certainly already seen some that in fact take command line arguments. What programs, what examples have we seen so far? Okay, since it's PIP, yeah, but I guess talking more generally about CS50 in the recent week. Yeah, exactly. So make, that's a really good segue into my next slide. So for example, make Mario, right? Mario is one of the command line arguments. We need to specify what program we need to make. So also what we'll see this week is, for example, Caesar, when you're writing your own sort of like cryptography algorithm, you will want to pass in some command line argument. But I think some folks already typing in the chat, but how do we actually, like build it into our main, right? Before we only had void, so sort of like nothing passed into main, and we just use get string and get ints to get users input. But the way that we sort of like upgrade it, right, is by specifying these arguments that main will take, specifically int RGC and then string RGV, right? By specifying this at the very beginning, we can ensure that the computer is indeed expecting some command line arguments. Well, what do RGC and RGV mean, and what is the difference? The comparison that I found very helpful is to think about exactly sort of like what RGC and RGV stands for. So for example, RGC is argument count, and then you can make the connection that int and count is a number, right? So even intuitively, if you might not even know all the details of RGC or RGV, you can maybe guess that RGC stands for the number of command line arguments, right? Like the number of them that we pass in. And then what about RGV? Well, RGV is argument vector, right? So you can make a few sort of like comparisons here. So RGV is an array, right? It is an array of strings, so it can hold multiple values. So that is the connection with the vector, but also like string and vector, right? Like some words, some tags that you see in the terminal. I think making this connection certainly can like bridge this gap of like, whoa, we introduced this new thing. How do we work with it? Well, let's see some more examples. So going back to our Caesar example, which some folks might already start on the problem set, but if not, this is what you might see. The first word that we have, Caesar, will be RGV 0, right? It is the first element. And then 13 is RGV 1. And what is our RGC, the argument count? How many? 2, exactly. So we have 2 command line arguments, so RGC will be equal to 2. And using RGC and RGV will really help you sort of like filter out the content that you want to get from the user. Say you always want to get that number like 13 or 14, like you always need that code, so you can even specify, well, if I'm not getting RGC equals 2, then something went wrong, right? Exit and then ask the user again or restart the program. So these are all really helpful tools to kind of like take our next step in this world of programming. And let's go back to our alphabetical program that we wrote just now, and let's think how we can incorporate CLAs here, right? So for example, instead of getting get string, instead of getting user's input through get string, I might want to do something like that, where I specify that my word will be hello, and it will indeed be stored in the second cell of my RGV array. And then alphabetical will be RGV0, my RGC equals 2. And in this way, I can sort of like bypass get string altogether and then just get the input from the very beginning from the terminal. So it is called RGV and RGC by convention, so this is what we're going to use. I'm just going through other questions in the chat. Okay, so now that we've seen that we could indeed use CLAs with our alphabetical program, let's go back to CS50.dev and actually try to code it. So let me clear the terminal. And let's start making some changes, right? So I'm going to leave this part, right? This is still what I want to have. This is my algorithm, but the part I'm going to change is this one. I'm going to delete this part, and I'm going to change void, right? Now I want to use command line arguments. So the way that I change it is by specifying int RGC, comma, string RGV, and I'm going to say that it is an array, right? So by specifying this in the very beginning, you're ensuring that you can use command line arguments. Well, what is next? Now I need to get the input, right? So the user typed in hello, and where I can retrieve it from, well, I'm thinking it is some input to the terminal, right? It's not just like how many command line arguments there are, so I'm immediately thinking RGV. So I'm going to create a new variable called text. And in here, I'm going to say RGV, but RGV is an array. So we need to specify exactly what value we are, oh, thank you, typo. Exactly what value we're looking for. And if we go back to the slide, it is RGV1, right? So alphabetical is the name of the program, and so it's counted as the first command line argument. And then hello is the second one. So we indeed want to grab RGV1 from our array. So let's do this here. I'm going to specify RGV1, and everything else should stay the same. I'm going to get my terminal back. Okay, so let's try making this again. Okay, it compiles, and now let's run it. Okay, so something went wrong. What did go wrong? What might have gone wrong here? Exactly, there is no RGV1 value. I didn't specify anything. So to fix that, I can say alphabetical hello, and now it will tell me no in the end, but this is sort of like the educational example, like the pedagogical example. So if we don't specify the argument, the program will then try to go grab the second value in RGV, but it is not there, right? So it's trying to access something that doesn't exist, and we get the segmentation fault, but maybe the user doesn't even know what it is. So how can we safeguard our program from running into this issue? What sort of like conditions can we set, or error checks can we set to avoid this? Okay, so use RGC. I'm seeing some answers here. In what way do we want to use RGC? Exactly, so if RGC equals to 2, and maybe even reverse it, right? So if RGC does not equal to 2, then I'm just going to say, please provide a word and return 1, right? So by specifying this if statement and having this sort of like printed out sentence in the terminal, I'm telling my users like, hey, you did not give me the word, right? Like I didn't get my second argument that I need to run my program. So we're going to exit, and I'm going to signal to the user that they need to provide this second word, okay? So let's try to run this again. So I'm going to make alphabetical, and I'm going to say alphabetical without the argument. And voila, it says, please provide a word. Okay, so that's working great. And now let's try with hello. It says no. And then let's try with ABC. That should be in alphabetical order. And it says yes. But what happens if I say A to B, G, whatever? It's not a string, right? I'm putting in some numbers in there. So sure, it's not in alphabetical order, right? But it is not exactly what oops, I got rid of my terminal. Okay. So I'm going to restart it here for a second. If I'm putting in an argument that contains some numbers, right? It is not really a string. It has some numbers in it, and maybe it is okay for determining the alphabetical order because it's not true technically, but how do I ensure that I indeed just get characters, right? There are no numbers, there are no special symbols, no exclamation mark. How can I ensure that? What other sort of like check can I make to ensure that I'm only getting characters here? Okay, so I can check the ASCII code. Yeah. Is alpha, right? So that is a really helpful function, and you can also look it up on manual CS50 pages, but is alpha will essentially tell me if the character is alphabetic or not. And to do that, I can again set up a for loop. So right here, what I'm going to do is set up the for loop like we always have done. I is less than strlen text I plus plus. And then for each character, I'm going to check if it is alphabetical. So is alpha on text I, because I want to look through every single character. So if it is alpha, I want to keep going. So maybe I want to set my condition to not alpha. And if it's not alpha, I'm going to say this is not a letter. And again, exit, right? Finish the program. Okay, and then I'm going to move this guy above just to make sure that it is top to bottom, and my program actually knows what text is by the time it gets to the second for loop. And I know this escalated rather quickly, and now there is a lot of code, but let's walk through it step by step. So in the very beginning, we are setting up CLAs, right? So RGC, RGV, necessary steps to ensure we have our command line arguments. Then the second step is ensuring that we indeed have two of them, right? That we have this word that we're going to work with. And so if it is not equal to 2, we're going to exit and ask user to provide a word and not nothing. Then in the second for loop, what I'm doing is going character by character, checking it if it's alphabetic or not, and if it isn't, I'm going to return an exit code, in this case 2. I'm sort of just like distinguishing between the different errors, and I'm going to print out to signify to the user that this is not a letter. So I'm saying commenting on every part. I should add some comments, right? This, I've been adding things without really commenting it out, just under one comment. So this would be a really good habit to get into. And then this last part is something that we, coded some time ago, just going through each character by character and checking if it is alphabetical or not. Okay, let's try to make it. Let's see if I didn't make any mistakes. And I did. So let's try to figure this out. Okay, so I used its alpha function, but I didn't include the library, right? And this is exactly what this error is telling me. I need to include the C type H library. And it is okay if that happens to you, right? You might not know exactly what functions are in what library, and thankfully the program will just simply not compile if you forgot to include the library. So let's make this again. Let's clear the terminal. Let's run it. ABC, yes. And then if I type hello, no. And then if I type something like 1, 2, 3, 4, 5, this is not a letter, right? And then if I don't type anything at all, please provide a word. So as you're working through these problem sets or even exercises, right, a good habit to get into is thinking like, okay, what if the user is providing not the input that I want, especially as we're leveling up to command line arguments where the user now sort of has like free will of what they can pass into your function. And so it is your responsibility as a programmer to ensure that you're getting the right input that you want for your function. And so coming up with these sort of like guardrails and error check is a really good habit to get into. Okay. I know this was a lot, and definitely feel free to go back and watch the recording, but in the meantime, what questions do we have about this exercise? Yeah, so someone says, why did I use return 1 here and return 2 here? Again, it sort of doesn't matter. But by convention, we return 0 if the program ran successfully, and then 1, 2, 3 is sort of like to signify different errors. So for example, return 1 will signify that the user did not provide enough arguments, sort of like that exit code, and then exit code 2 will signify that one of the characters in the string was not alphabetical. Okay, let me try to get through all the other questions. What is the difference between RGC and RGV? Let's go back to our slides. So RGC is the argument count, right? So how many command line arguments did we see in the terminal? An argument vector is exactly those command line arguments, right? So RGV is the array of type string that will store these command line arguments. Notice how we don't specify a size for RGV, right? This is sort of like where it's the hidden, like magic behind the scenes. And so it will automatically update with however many command line arguments the user put in. But I hope this explains the difference. What other questions do we have about this program or arrays, command line arguments, strings? What do we use most, RGC or RGV? That's a great question. I guess depending on the purposes, right, of your program. So RGC might be really good for checking if the user put in the argument or they didn't. And then RGV is mostly for like grabbing exactly, like the value of them, like the exact word or name of the program or anything else. Okay. Yeah, so sort of like command line arguments and getting user input is like the interchangeable thing. Before we've only seen get int or get string or get float, but those are only local to CS50, right? It is in the CS50 library, and that and it's only sort of like local to this class. Command line arguments, on the other hand, is like a worldwide thing, right? So in this case, we're just stripping off our training wheels and leveling up a little bit more to get rid of the CS50 library. Yeah, so let's see. Someone said there might be an error with this part. So if you want to instead use I+1, you will just need to tinker the initializations right here. So instead of I, you might want to say 0 and then just like stopping a little earlier. And in fact, while I'm on these for loops, what is one thing that I could do better about these for loops? I think David mentioned in the lecture, and I was meant to ask you guys earlier, but I got a little carried away. What could I do better about these for loops? So Okay, seeing some suggestions. What I'm trying to allude to, right, is that right now, every time I compare if I is less than the length of my word, I run the function, I run the function, I run the function. Instead, what would be better design is declaring it in the first part. So for example, I'm gonna call it len, and then instead of running the function every time, I'm going to move it this way and then just compare against this variable here. Okay, so this will be better designed, right? Because I'm only using strlen one time on my word, and then after that, I can keep reusing it just as a variable. Okay. And last call for questions. Anything that I could clarify? Yeah, so someone's asking, for example, for debug 50, I think we're running out of time, but there's this wonderful short on the second week of CS50's, on second week of CS50 page, where there is a short about debug 50 and a few examples of how to use it. Is it possible to declare more variables in the for loop? Sort of yes and no. I guess nothing is stopping you from it, but if we just kept declaring, variables right here, it would just get too long. So we can do it with I and len because they're just like native to the for loop that we're using. But if you're reusing a specific variable multiple times, it might be better to declare it outside. In fact, now that I'm looking at it, right, I'm using strlen twice in here. So it might be even better to declare it up top, right here, run it just once instead of running it every time I use a for loop. Right? Okay. All right, so let's go back to the slides, and I'm going to sum up here. Thank you so much for coming. We'll be here every week at 11:30 Eastern, so feel free to tune in or watch the recording afterwards. Thank you so much for coming, and I hope you enjoyed this week's lecture and all the future weeks.